Hello students, today we will start a new chapter, Motion in a Plane. As we have completed the chapter Motion in a Straight Line, in that chapter we described one-dimensional motion, the concept of position, displacement, velocity and acceleration, and how they are essential. Further, there are many directions in 2 or 3 dimensions in which an object can have displacement, velocity or acceleration. For dealing with such a situation, the concept of vector is introduced. In this unit, we will study the vector concept. Later, we will study the motion in a plane, the projectile motion and the circular motion. So, in today's class, we will study about physical quantity, in-physical quantity, scalar quantity and vector quantity. Then the difference between scalar and vector quantity and how this vector is represented, that is vector representation. Then types of vector, and will define position and displacement vector. Then we'll understand multiplication of a vector by a real number, then addition of vectors and laws of vectors addition, that is triangle law of vectors addition and parallelogram law of vectors addition. First, we'll study about physical quantity. A quantity which can be measured is called a physical quantity. For example, length, mass, time, speed, momentum, acceleration, force, work, power, etc. So, length can be measured. A quantity which can be measured, which all can be measured, are all the physical quantity. Measurable quantities are all the physical quantities. Like length we can measure, mass we can measure, time we can measure, speed we can measure, so on. We can measure the quantities and those quantities are called as physical quantities. So in physical quantity there are two types. One is scalar quantity and the other one is vector quantity. Now we'll study about the scalar quantity. A physical quantity having only magnitude but not direction is called scalar quantity. For example, we'll take mass. This mass has only magnitude like 5 kg, 2 kg, 3 kg, grams or anything. But it doesn't have the correct direction, right? We don't say 5 kg towards north or towards south. Okay. The quantity or a physical quantity having only magnitude but not direction is called scalar quantity. So for the scalar quantity, mass, distance, time, speed are the examples. Next, moving to the vector quantity, we'll understand it. A physical quantity having both magnitude and direction is called vector quantity. So for example, we'll take about the displacement, as we have studied this displacement in a earlier chapter. So displacement is what? It's the shortest distance between the 2 points. It has a particular direction and also it has a magnitude. Like 10 meter towards a north or a south, it has some particular direction. We assume the particular direction in displacement, and also velocity, momentum, acceleration, force, etc. Right? So a vector quantity is a physical quantity having both magnitude and direction is called vector quantity. Next, we'll study the difference between scalar and vector quantity. So in scalar, as we have studied, has only magnitude, but in vector, it has both magnitude and direction. Next is scalar quantity obey ordinary laws of algebra, but vector quantity does not obey the ordinary laws of algebra. Next is that scalar quantity, they changes if the magnitude changes, but vector quantity, they changes either the magnitude changes or direction changes or both changes, they change. Next, in scalar quantity, they're represented by ordinary letters, whereas the vector quantity is represented by either by bold letters or letters with an arrow mark on them. Let's study the vector representation. The vector is represented by a straight line with an arrow mark. This arrow mark indicates the direction at which the vector is produced, and this OP represents the magnitude of the vector. So we can represent this vector with A. So for better understanding, let us consider the object moving from south to north with a velocity of 20 meter per second. This can be represented vectorically by drawing a line of length 20 centimeter, where we can say that 1 centimeter is equal to 1 meter per second. So in this way, we can represent the vector, and the arrow mark shows that it's towards north direction. Let's study the types of vector quantity. Equal vectors. Two vectors are said to be equal if they have same magnitude and same direction. As you can see in the figure, A vector and B vector having same magnitude and they're going in the same direction. So these two are said to be equal vectors. Next we'll talk about the unit vector. Unit vector, a vector whose magnitude is 1 is called a unit vector. Negative vectors. Two vectors are said to be negative if they have same magnitude but opposite direction. As you can see, a vector A is moving towards the right and vector B is moving towards the left. So they have same magnitude but they are going in an opposite direction, so they are called as negative vectors. Next is concurrent or co-initial vectors. Vectors having the same initial point are called as co-initial vectors. See, vector A, B, C, D, these all vectors have a same initial point. This is called as concurrent or co-initial vector. Let's define position and displacement vector. A vector that gives the position of a particle at an instant with respect to the origin of a coordinate system is called position vector, or it can be defined as a vector drawn from the origin of a coordinate system to the position of a particle at an instant is called position vector. This position vector gives the position of a particle at an instant with respect to the origin of the coordinate system. Next, we'll define the displacement vector. It's nothing but a directed line segment from initial to the final position of a particle in a given interval of time is called displacement vector. Let's study the multiplication of a vector by a real number. When a vector quantity is multiplied by a real number, the resultant physical quantity obtained is a vector quantity. If the real number n is positive, then the resultant is n times the magnitude of the given vector and the direction is same as that of the given vector. Next, if the real number is n is negative, then the resultant is n times the magnitude of the given vector and direction is opposite to that of the given vector because it is negative. Let's see how these vectors are added. That is addition of vectors. When two vectors acting in the same direction, as you can see, let A and B be the two vectors acting in the same direction. To add these vectors A and B, the tail of B is placed at the head of A. Then a single vector R drawn from tail of A to head of B gives the addition of A and B. Therefore, R, which is a resultant vector, is equal to A plus B. Let's study the laws of vectors addition. Let's state the triangle law of vector addition. If two vectors can be represented both in magnitude and direction by the two sides of a triangle taken in the same order, then their resultant is represented completely both in magnitude and direction by the third side of a triangle taken in the opposite direction. Let's understand. Let's see the triangle ABC. AB is equal to vector P, BC is equal to vector Q, and AC is equal to vector R. Let P and Q be the two vectors represented both in magnitude and direction by the sides AB and BC of a triangle ABC taken in the same order. You can see the arrow mark, they are taken in the same order. But the resultant R is given by the third side AC of a triangle, as you can see in the diagram. It is taken in the opposite direction or the opposite order. From triangle law of vector addition, we can write this as a resultant AC is equal to AB plus BC. This is the law of vector addition. Let's study parallelogram law of vectors addition. It states that if two vectors acting at a point can be represented both in magnitude and direction by the adjacent sides of the parallelogram, then their resultant is represented completely both in magnitude and direction by the diagonal of the parallelogram drawn from the same point. From figure, let vector P and Q acting at a point O be the two vectors inclined at an angle theta. Let them be represented both in magnitude and direction by the adjacent sides OA and OB of the parallelogram OACB. Now, according to the parallelogram law of vector addition, the resultant R of P and Q is represented both in magnitude and direction by the diagonal OC of the parallelogram drawn from the same point. As you can see, this R is the resultant vector, which is a diagonal of a parallelogram OACB. So this is the parallelogram law of vector addition. So in the next class, we'll study resultant of a two concurrent vectors. Thank you.